In this lesson, we're going to be talking about translations. By the end of this lesson, you should be able to slide a line along the x and the y axis. You should be able to write the equation for your new line, and you should be able to describe the type of translation that is occurring. When we talk about a linear translation is a line, or is a slide, or a shift of the line on the graph, either vertically, horizontally, or both directions from the original function. Sometimes the function that we are translating from is called our parent function. Your parent function for all linear graphs is going to be f of x equals x. Anytime it doesn't specify a different function to translate off of, we're translating off of the parent function. When we translate, remember that a translation only changes the location of the line, so it's not going to change the steepness or the direction of your line, which means that it does not change the slope. So when you're translating lines, you should end up with two lines that are parallel to one another. When we're translating along the x-axis, when you're moving along the x-axis, this is known as a horizontal shift, and we have some directions that it gives us. So when we see f of x minus a number, that is my direction to tell me to go right. And we go right for however many numbers or however many places that number value is. So if it was f of x minus 4, that would tell me to move to the right 4. So if we had f of x minus 4, this would say go right 4 units. So it's a little bit backwards. Usually when we think of minus, we think of moving to the left. But when we're talking about horizontal movements, if it's a minus inside the parentheses, that's telling us to go to the right. When we see f of x plus 4, this is giving, or f of x plus a number, this is giving me directions to go to the left. So if we had f of x plus 3, this would tell me to go to the left 3 units. So these are our directions. Anytime we have f of x minus a number or f of x plus a number within the parentheses, that is telling me to go either left or right. If it's minus, that's telling me to go to the right. If it's plus, it's telling me to go to the left. Now remember that when we're translating, the slope stays the same, but your y-intercepts should change because we're going to end up with parallel lines. When we're moving along the y-axis, this is known as a vertical shift, and our directions are similar but a little bit different than when we're moving horizontally. Notice this time the number, which we're using the variable d to represent this, the number is now on the outside. So we have f of x plus a number. If it's f of x plus a number, it's telling us to go up. If it's f of x minus a number, it's telling us to go down. So now we're back to reading it that normal way. So if it's horizontal, we need to read it backwards. So reading plus is going left and minus is going right. But if it's vertical, if it's on the outside, we're reading plus is going up and minus is going down. Again, the slope stays the same here, and the y-intercept is going to change. Again, we're going to end up with parallel lines. So regardless of if we're sliding horizontally or sliding vertically, our slope is going to stay the same while our y-intercept changes. Okay, so let's graph the functions to determine their effects. So here we have the parent function f of x equals x. What this tells me is that I need to start at 0, and then my slope is going to be 1. And so my graph for f of x equals x is going to look like this. Get my line. So here's what my line is going to look like. And then to get the translation, it's telling me to take f of x and to go down 2. So we have f of x minus 2. This would be a vertical slide, a vertical shift. And because it's minus, this tells me to go down 2. So to go down 2. So from my line here, I would move all of my points down 2. So I would take each point and I would shift them down 2. And here we would have our new line. So we graphed it, and the effect that we've determined is that this was a vertical shift, and it wanted us to move down 2. If we're looking at this next one, we have f of x plus 3. This is telling me that from my parent graph, from f of x equals x, so from my parent graph, we're going to go to the left 3. So this is inside, this is horizontal movement. If it's plus, remember that's moving us to the left. And because this number is 3, that tells me to move it to the left 3. So this says take all of my points that I have on my graph, on my parent function, and move them to the left 3 units. So if I take this 1, 2, 3, I'm going to have a point right here. 1, 2, 3, 1, 2, 3, 1, 2, 3. So all of my points move 3 places to the left, and that's going to give me my new line. And so we've graphed it, and I know that because this is a horizontal shift and it's plus, that's telling me to go to the left 3 units. If we're looking at this next one, it's wanting us to describe the change of the translation. So remember that when the number's on the outside, this is a vertical movement, so either up or down. If it's minus, we're moving down. And so this is a moving, and this one we're moving down by 2. So moving down 2. For the next one, for b, for g of x is equal to f of x minus 2, because it's inside the parentheses, this is telling us to move either left or right. Because this is minus 2, remember that we're reading this one backwards, so instead of going to the left, this is actually telling us to go to the right. So we're moving right 2. When we're looking at 4, given f of x equals 1/3 x plus 1, so this is not our parent function, this is a different function, but we're going to translate off of this one. So I'm going to graph 1/3 x plus 1. So I get my graph for that one. Okay, there's my line for 1/3 x plus 1. And I'm going to do the following transformation. So I have g of x is equal to f of x minus 1. What this graph tells me to do is it says take f of x, take your original graph, and move it down 1. Because the number's on the outside, remember that that's a vertical movement, so either up or down. Because it's a minus, that tells me to move down. So I move all of my points from my line down 1. So take my points, and go down 1, and I have my new line. Again, my line should be parallel, so it means I should have the same slope, but a different y-intercept because all we've done is translated. So we graphed the original line, we've graphed our new line, and we've described the change. Here we have f of 3x plus 1, so here's our original line here. Again, this is not our parent graph, but we're going to translate based off of this new graph. So we have 3x plus 1. Here's my graph for this. And this would be a horizontal movement because it's on the inside. Because it's a minus, I know that I'm moving to the right. And I'm moving to the right by 1 unit. So all of my points are going to move to the right by 1 unit. Again, I should end up with a line that's parallel, but moved over to the right one. The other thing that we need to make sure that we're able to do is to translate the function without using the graph. So in A, we know that we're translating up, and we know that we're translating up 3 units. However, we don't have a graph to be able to do this. So we're going to focus on the equation. So what this says when we have f of x plus 3 is it says take all of f of x, all of this function, and increase it by 3. So add 3 to it. Well, we go back to f of x, and we see that f of x is 2x minus 5. So what this says is it says take f of x, which is 2x minus 5, and add 3 to this whole function. And so when we do that, this is going to help us to write the equation. So now that we have this part, we're going to simplify. Okay, I no longer need these parentheses. There's nothing being multiplied to them, so I can drop them off. 2x minus 5 plus 3. And then I can simplify this. I can combine negative 5 and positive 3. And we'll find that k of x is equal to 2x minus 2. If we're looking at b, notice that this is written a little bit differently. Because the number's on the inside, what this one is saying is it says take your function for f of x. So take f of x, which is 2x minus 5, and evaluate it for x equaling 4, or for x minus 4. So what this says is it takes f of x and evaluate it for x minus 4. So what this is telling me is that in my equation, wherever I see an x, we're going to replace it with x minus 4, with whatever is inside this parentheses. So my new equation will be 2 times, and instead of x, now I'm going to have x minus 4 minus 5. And then I can simplify this. So we would distribute the 2, so this would give us 2x minus 8 minus 5. The parentheses are no longer there because we distributed. And then we can simplify and get 2x minus 13. And so for h of x, our equation would be 2x minus 13. So the biggest thing here is that if the number's on the outside, we are taking the whole function and adding the number to it. But if it's on the inside, we're evaluating the function for whatever was inside the parentheses. Before watching the next video, what I would like for you to consider is how, from an equation, do we know the difference between a horizontal and vertical shift. Please subscribe to the channel so that you get updates as new videos are released, and thanks for watching.